Okay, so I'm using t equals tan x over 2. I'm integrating 0 to pi by 2, 1 over 2 minus cos x dx. Okay, limits first of all then, these are x limits. So if x is 0, t is the tan of 0 over 2, which is 0. If x is pi by 2, t is the tan of pi by 2 over 2, which is pi by 4, and tan of pi by 4 is 1. Make sure you're on rad mode on the calculator. And then I've got cos x, the expression for cos x is in the formula booklet for me. Okay, on page 4, t is tan half a, then cos a is 1 minus t squared over 1 plus t squared. So I know that cos x 1 minus t squared over 1 plus t squared. I need to substitute for dx, so t is tan x over 2, so dt by dx, differentiating tan goes to sec squared x over 2 times the differential of x over 2 is a half, dx, sec squared is 1 plus tan squared, so that's 1 plus tan squared x over 2, and tan x over 2 is t, so this is 1 plus t squared, so cross multiplied 2 dt over 1 plus t squared is dx. So I substitute into here then, so the limits instead of 0 to pi by 2 is 0 to 1. dx is 2 dt over 1 plus t squared, and the bottom line is 2 take away cos x, which is 1 minus t squared over 1 plus t squared, so I need to deal with the bottom line, so 2 minus 1 minus t squared over 1 plus t squared. I scale the 2 up, so that's 2 lots of, to make the denominator the same. And, oops, that's a squared there, sorry. So that's all over 1 plus t squared, so that's 2 plus 2t squared, and minus 1 minus minus plus t squared, so that's going to be 3t squared plus 1 over 1 plus t squared. So coming back to the integral, that's 0 to 1, 2 dt over 1 plus t squared over 3t squared plus 1 over 1 plus t squared. Second and fourth line are the same, so they'll cancel off. Give me the integral from 0 to 1, 2 dt over 3t squared plus 1. Okay, so I need to take the numbers out, and then I look for the standard integral from formula booklet. So take the 2 out and take the 3 out. So it's dt on top, and taking the 3 out of the bottom, that'll be t squared plus 1/3. And on the standard integral, integrating t squared plus 1 over 3. It's this format where, okay, so I'm using the integral of 1 over a squared plus x squared is 1 over a tan to the minus 1 of x over a, where instead of x I've got a t, and a squared is a third, which a is 1 over root 3. If I square root 1, I get 1, square root 3, I get root 3. So this is 2/3, and it's 1 over a, so that's 1 over root 3, tan to the minus 1 of t over 1 over root 3, 0 to 1. It's looking a bit of a mess. That fraction flips up on top, so that's 2 root 3 over 3, 2/3 there, that flips up to root 3, tan to the minus 1, that root 3 flips up on top, that's root 3t, divided by 1 is just root 3t, 0 to 1, just 2 root 3, tan to the minus 1, put 1 in there, that's just root 3, minus 2 root 3 over 3, 10 to the minus 1, put naught in, that's naught. 10 to the minus 1 and naught is naught, that's gone. 10 to the minus 1 root 3, make sure you're in rad mode. I'm in rad mode here. Shift 10 of root 3, we should know it, but put it in there. That's pi by 3, so that's 2 root 3 over 3 times pi by 3, which is 2 root 3 pi over 9. And to evaluate that, then gives me the value. I'll just calculate that out. So that's 2 root 3 pi on top, 9 on the bottom. There's only 1.2091999576. I'll go to 2 decimal places, it's equal to 1.21.